The Autodesk Construction Cloud connects planners, engineers, contractors, and owners throughout the project lifecycle in one common data environment as the workflow progresses from planning to design, into construction, and finally to operations. The Autodesk Construction Cloud acts as the centralized hub for data storage, project coordination, and communication through the major project milestones. Starting with the planning phase in this example, a two-lane road connects a freeway interchange to a major subdivision and needs to be expanded due to demand. Owners and planners can utilize the tools within InfraWorks to analyze traffic simulations as part of the purpose and need study. Environmentally sensitive areas can be identified and included in the study to aid in the alternatives analysis. Various alignments and road configurations can be created and evaluated for functionality and feasibility in their contextual environment. These design alternatives can be stored and accessed within Docs in a customizable folder format. Additionally, anyone with project access permissions can view the InfraWorks model in the ACC viewer. In the design phase, existing conditions can be collected and detailed design can proceed. Using the Autodesk connector for ArcGIS, designers and engineers can compile libraries of data that can be easily added to their Civil 3D drawings, providing existing conditions and features for their projects. Once this data has been assembled, teams can share CAD files and surfaces with other disciplines using the Design Collaboration module. The other teams or disciplines can consume these shared files and use them as a reference or base files in their design process. Detailed design can be done efficiently with Civil 3D, where the roadway alignment, both the horizontal and vertical geometry, can be created and modified. Roadway assemblies can be developed to create a detailed corridor model. Designers and engineers can harness the power of design automation by using Dynamo for Civil 3D to add additional elements to create a complete roadway model. Engineers can also use the tools within Civil 3D to fully inspect their models for any issues. Earthwork quantities can be calculated and displayed in the cross-sections. Structural engineers can utilize the corridor model to develop a bridge in InfraWorks, where they can determine all the bridge materials, dimensions, and parameters. They can take this same model into Revit, where they can review the bridge layout and section details. They can also fully configure the rebar details. Plan sheets can be set up and easily maintained in both Civil 3D and Revit. When the plan sheets are uploaded to the project, the Autodesk Construction Cloud will scan the drawings to assign sheet numbers and titles based on the sheet content. Sheets can be accessed and reviewed by the project team in the office or in the field. The sheets and files can be used as reference documents during design reviews. Reviewers can add callouts, markups, and comments to the files to communicate problems or design issues. The reviewer can then set the review status of each sheet and file. A comment report can be easily exported to an Excel spreadsheet. As the project moves into the pre-construction phase, engineers and contractors can coordinate model details to include valuable metadata. Designers and engineers can add pay item data to the corridor and easily extract the summary of quantities. This pay item data can be reviewed and displayed in the roadway model. The same files can be viewed in the ACC viewer, where the same metadata and property set information can be viewed and documented. The Model Coordination module adds valuable insight to the constructability review process. Model views can be set up to review general or specific model details. The clash detection feature allows engineers and contractors to review any potential conflicts prior to construction, thus helping to avoid costly rework and in-field conflicts. This information is then stored as an issue and can be reviewed and assigned to the engineer of record. Once the design is updated, the engineer can post the updated model and compare the changes to ensure that they have been made. Construction schedules can be added in Navisworks to simulate a 4D build sequence to outline construction steps and feasibility. Next in the build phase are field execution and the closeout of project issues. In the field, the contractor can create an RFI to request project details. They have full access to the model and sheet files and can provide markups and comments on the plans. The contractor can also add images from the field. This information can then be assigned to a field inspector who can provide additional details or reference information if necessary. The RFI can then be assigned to the engineer of record who can make any needed changes as a result of the RFI. The RFI will track the entire request history and can be closed for distribution. With this project access, the contractor can also provide as-built data from the field and note changes on the drawings. As changes are made based on field recommendations, that information can be communicated back to the engineer where updates can be documented. The model and the plan sheets can then be updated as necessary. These issues can be tracked by the team to ensure proper project closeout. In the final phase of operations, the owner has access to all the documents and the aggregated model created in the course of the project lifecycle. Specific asset data and property set details can be utilized to provide more information about specific project elements. Final project details can also be published to ArcGIS for future access with the same attached metadata. Through the BIM 360 and ArcGIS connection, the project files can be accessed and referenced to provide a complete digital twin model. The final model reflects the correct geometric details as well as the metadata required for asset maintenance and operations for the lifespan of the infrastructure. The Autodesk Construction Cloud helps to manage and complete the critical milestones without costly data loss through all phases of the project lifecycle.